All right, good morning, everyone. Today we're going to talk about causal analysis. So far in the course, you learned that regression results cannot be interpreted as causal. And we also learned that if we do experimentation, for example, A/B testing, then we can interpret the result of those experiments as causal, right? So usually in data science, we deal with observational data. This means data that was already collected. And typically, with observational data, we cannot make causal claims. So the usual practice is that if you want to make causal claims, you have to conduct experiments, and it is the result of the experiments that allows you to make those causal claims. However, there's a trick. The trick is what we're going to learn today. So there are some methods, such as propensity score weighting, that allows you to make causal claims under some strong assumptions using observational data. And that's why this method is popular in data science. So this is the topic for today. So the method we're going to use is propensity score weighting. So for learning how this method works, I've prepared an example. We're going to go through it. And you will see how you can use data that is already collected for making a causal claim. So this is the setup for the example. Imagine that you want to make causal claims about the impact, the causal impact of participating in a job training program on earnings 3 years after the program. So there is a job training program, and the idea is that people who participate in that job training program will be able to secure better jobs with higher salaries. And we want to answer this question of what is the causal impact of the job training program on the earnings of those who participated in 3 years from the time of participation. And we want to know the effect size. We want to know by how many dollars on average their income would change in 3 years after the job training program. So this would be our treatment variable participating in the job training program. And we want to know its impact on another variable, which would be earnings in 3 years. So we need to have data on both of these, right? This is our y variable. This is our treatment variable t. So you can imagine that we have a data set that has a column for t. T is a binary variable. It's 0 or 1. So those who participated, their t variable equals 1. And we have a y variable, which is their income in 3 years. So imagine that we have data on 10,000 people, and out of these 10,000 people, like 170 of them participated in the job training program. So we have 10,000 rows in this table. For each person, we have the salary in 3 years after the time of that job training program, and we know who participated, who did not participate. So this is the outcome variable. This is the treatment variable, and we represent them by circles in a diagram called a causal diagram. So that's step 0 of this process. So when we draw the diagram, there are arcs connecting these variables to each other. So since we're interested in the impact of t on y, the arc goes from left to right. So we are essentially interested in quantifying the effect size that we have from t to y. But what are the issues? One issue is the confounding bias, the fact that there can be other variables that impact both t and y. And those confounders prevent us from calculating a reliable effect size if we use, for example, univariate regression. If you just have these two variables and fit a univariate regression of y on t, the issue would be confounding. The fact that salaries of these people will be different from each other, and there will be many reasons for that difference. For example, they have different age. For example, they have had different jobs at the time of that job training program, right? And these will be potential confounders. So in this method, these potential confounders are called covariates. So don't confuse the term with a covariate matrix. This is just a term. Covariate here means that while we're interested in how changes in t lead to changes in y, there are some other things varying in the background. That's why they are covariates. Another name for them is the pre-treatment confounders, meaning that before getting to the point where people participated or did not participate in the job training program, there were other reasons why these people differ from each other. So before being exposed to this treatment, there were these confounders that can impact differences in their earnings in 3 years from now. So how do we do this? How do we use propensity score weighting? One way of doing propensity score weighting involves using inverse propensity weights, IPW. If you want to do causal analysis using PSW, for which the weights are inverse propensity weights, you can do it by drawing a causal diagram and then following 5 easy steps. So what I'm going to show you is how we draw the diagram, and then based on what we see in the diagram, we would know what we need to do in those other 5 steps. And under some strong assumptions, and if those steps work correctly, then at the end of the process, we will be in a position where we can make a causal claim about how many dollars the earnings would change in 3 years if someone participates in this job training program. And that would be a causal claim. So it wouldn't be just correlation or association. We can say that it is participating in the job training program that accounts for that increase in salary. Questions? All right, so what do you think are some potential covariates? What do you think are some potential confounders that we have in here? Just imagine 2 people who have different salaries. Why do you think they have different salaries? Years of experience. So, of course, the salaries generally increase with years of experience. People normally start with a starting salary, and then in their role, they get promotion, and the salary increases. Even if they change company, for the new company, the previous salary is a factor in the negotiation or where they start, with the new company. That's why the years of experience is relevant. But we can also include years of experience kind of differently using a more direct variable. So the more direct variable that I can think of is previous earnings. So the earnings in 3 years must be related to earnings or income 3 years before that, right? Because it's not just, the income is not just some variable in vacuum, but it is essentially a temporal variable, and this is a snapshot. This is a kind of a snapshot in time for that variable, and there are different snapshots for that variable. So we can consider previous earning as a potential confounder. So in a causal diagram, these covariates are represented by rectangles. Now that we identified this potential confounder, we need to think about its arcs. So ideally, all potential confounders that impact both t and y must be included. So thinking about previous earnings and earnings in 3 years, do you think the causal link is from left to right or from right to left? This is easy. It is left to right because of nature of time, right? So that's why we draw the arrow like that, and it's very crucial that we get the direction of arrows correctly in the causal diagram. previous earnings also have some relation with the job training program. Imagine that this job training program wasn't freely accessible, so people had to register and pay a certain cost for it, right? So we can say that this confounder also impacted how people ended up participating or not participating in this. So therefore, there is also a link connecting these two. So for that arc, you think I should draw it from right to left or left to right? So since it is how much disposable income they have, which matters for whether they can afford or how well they afford the job training program, the arrow would be from right to left. So this was the first covariate that we identified, but we need to continue. So normally, in a causal analysis, the process for drawing the causal diagram may take many hours or a few days. So you really need to sit down and think about potential confounders. If this is a topic that you already have some ideas about, such as this, your understanding of how the world works helps you draw the diagram. In other cases, if let's say you're working on a topic related to alcohol consumption and heart disease, right? Then, if this is not your field of expertise, then you need to read the literature and see what are the well-established effects and relations between these variables, what are the other confounders that are relevant. For example, other types of drugs might be related because when someone drinks, it impacts their propensity for using other drugs, or it impacts their propensity for smoking, right? That's why other drug use or smoking should be relevant. And either you know that from your understanding of how the world works, or you study and you read papers, and from those papers you realize what those confounders are. And typically drawing the causal diagram is something that happens much, much slower than how we're drawing it here in class. All right, so again, imagine those two people who have different salaries. So except for the fact that their salaries 3 years earlier might have been different, what are the other factors that explain why they have different salaries?
Level of education.
So again, education is a variable for which there is well-established evidence that it impacts, economic variables like income, right? So education is a potential confounder. If those two people in your mind have different incomes, one reason why they have different incomes can be the fact that one of them has a master's degree, the other one has high school level of education. So again, for education, we need to think about the direction of arrows. So education and why. So do you think the arrow should be left to right or right to left? Yes?
Left to right.
Left to right, because it is the education impacting income generally, right? So that's why we draw this arrow, this arc like this. And education and job training program. Again, imagine in our example, I should have explained this more in the setup. Imagine that a job training program was advertised more often in universities and colleges and educational institutions. Therefore, someone who is studying, had more exposure to seeing those ads and learning about the fact that such a job training program exists, compared to the average person who is not active, in university or who's not a student and so on. They wouldn't see the ad. So based on this explanation I gave you, the arrow for education and job training program, you think it should be from left to right or right to left?
Left to left.
So it would be like this. It is the education that changes the exposure of people to learning about that job training program, and they need to know about it to make a decision on whether they want to participate or not. So other confounders. Yes, Evan?
Do we have to link education and previous earnings as well?
We don't. This is because here we're trying to find all the causal pathways. So on this diagram, whenever we go from left to right, when we start from T, go to other nodes in this graph and end up in Y, that path is called the causal path, causal pathway. So we can imagine that one causal pathway is the direct causal link, which is what we want to identify, right? Another one is what we call a backdoor. So if we go from T to previous earning to Y, that is a path. And this path goes against the direction of this arc. That's why we call it a backdoor, right? So it's essentially the confounding effect that previous earning has, and if we don't adjust for it, it represents itself in the main effect that we would have in a univariate regression of Y on T, right? And to keep things simple, I'm not going to make a link between education and previous earning because the reason why they are in the diagram is for us to identify these so-called backdoors. But there can be examples where things get more complicated, and you can also have links between these confounders. All right. Imagine, again, those two people who have different salaries. There's another kind of obvious confounder. It kind of depends on what you're imagining.
Motivation and also kind of area they live or something?
All right, motivation. Well, motivation is kind of difficult to measure, right? That's one issue with it. I'm not saying that when something is difficult to measure, you shouldn't include it. But this, besides the fact that it is difficult to quantify, here we're talking about average effects, and you need to think about averages. Of course, motivation is relevant, right? But it's probably not as strong compared to education, which is something that is well established in the field to be a relevant factor for income, right? So that's why we're not going to include motivation. But as we're going to continue this, we may end up with some other variables in our diagram that may have something to do with motivation, or maybe a proxy that also account for motivation, or motivation would be a part of those variables. Another sort of obvious confounder.
Job performance over the 3 years since, and then job performance before.
But again, this is a good idea. It is kind of consistent with our understanding of how the world works. But you need to think about a variable that can be measured for like 10,000 people. These 10,000 people are in different industries, in different companies, and there is no one, sticking measure for quantifying a universally agreed upon notion of job performance, right? So that job performance is probably somehow baked into this in a sense. If someone has substantially better job performance, probably also their earning compared to the person with the similar characteristics but lower performance, they must have lower previous earnings. So it's kind of already in.
The company that they work for example, if someone works at a bank,
Yeah.
their salary, we can expect their salary to increase in 3 years versus someone who works at a startup maybe.
So the company that they work with, again, that is kind of captured here in previous earnings. So if you're talking about like a tech company versus, let's say, entertainment company, and the fact that, for example, the salaries in tech companies are high, let's say compared to hospitality industry, right? That is already here. But there is one important confounder. I'm trying to see if I can get it from you. Gender is also relevant for sure. If we read the literature, gender affects pretty much every socioeconomic variable. But again, in the current state of the world, where gender makes a difference for salary, it is kind of built into this. Age, exactly. So if those two people in your mind are like a relatively senior person and a relatively young person, and you see them for the first time, and you learn that one of them has a salary of 200,000, the other 50,000, would you be shocked to learn that difference? No, because for you, it's obvious that one of them is an old man, the other is a young, graduate fresh out of college. So you wouldn't be shocked that they have 150,000 difference in annual salary, right? That's why age is definitely relevant, and we include age here. And there are some general rules about it. So we have the notion of unimportance, the notion of redundance, and the notion of irrelevance. So pretty much for any confounder that you think of, you need to check these three notions to see whether you should include it or not. Here, I would argue that age is an important variable for this problem. But generally, you need to kind of question your choice and kind of challenge it with the same arguments, especially involving irrelevance, unimportance, and redundance. So now age is in, so age and y. So I think it's kind of clear where the direction is, right? It's not like, well, there are some attempts of rich people trying to reverse the process of aging. You might know about that tech billionaire in US trying to reverse aging. And he does look, if you know who I'm talking about, he does look much younger than his legal age. But except for that, the direction is that it is the age impacting your income, not your impact, not your income impacting your age. And again, I should have explained this more in the setup, that imagine this job training program. The people who would go to that job training program are from a specific age group. So like there will be variation, but there will also be a range. And therefore, for someone maybe in their 60s, maybe they feel kind of weird going to a job training program where everyone is like 40 years younger than them, right? That's why also age impacts the propensity that someone participates, right? Because of the social awkwardness of someone participating in an activity where everyone is from a different age group, from a substantially different age group. Just imagine that job training program where most participants are, I don't know, like between teenagers to like their 30s, right? You wouldn't see someone in their 60s there. Why? Because probably they would feel, even if they see a benefit in participating, they would feel that social awkwardness or just the patterns that lead to people kind of hanging out with others from the same age group. Maybe that would be the mechanism. But you can hopefully see that age also has an arc going to t. So what we have currently on the diagram is a diagram with 4 causal pathways. 3 of them are backdoors. 1 is a front door. So what we want to do is to close all the open backdoors by adjusting one variable on that path. So here, with my easy example, the paths are paths of 2. So there are only 2 arcs. And the variable on the path would be these confounders. So this means that in our propensity score weighting, we need to adjust for age, education, previous earnings to be able to identify the causal impact of t on y. So, all right, I'm going to make this example a bit more specific and less general because I want to also tell you about some concepts that we have in causal diagrams. And now maybe the example becomes too specific, but this is because I want to teach you some concepts about what you may come across in these diagrams.
Whenever we're finding a confounder, is it important that we must always establish relationships between the confounder and t and y?
Yes. So variables that have association with both t and y must be included.
I'm trying to understand if, I don't know, for some scenario, can we include age if it only affects y and not t?
No, you don't need to do that. You would include it, and then when you look at the diagram, you're going to see that it is just a node connected to this that is not connected to the rest, and it's not part of any pathways. Then you decide to remove it. So if you find variables that impact both of them or are associated with both of them, they must be included. But let's say you find a certain variable that is highly relevant, but it only has association with y, then it wouldn't be part of any path from t to y. That's why in a later stage, you're going to get rid of it. You're going to remove it.